We're going to be looking at limits in general, and it could be seen as being the value that a function approaches as it gets closer and closer to a point without actually being at this point. Here's an example of a limit. What is the value of this function as x gets closer and closer to 2? Well, if I want to take the limit, I could come at it from below and I could try values like x equals 1.9 and 1.99 and 1.99999, and from above I could say, well, I'm going to look at it when x is 2.1 and 2.01 and 2.001. Now this one actually though is very trivial because the function exists when x is equal to 2, and so what I can do is actually look at the value of the function and substitute a 2 in there, and this one is actually just equal to 5. So here's a second example. What is the function x squared minus 1 over x plus 1 as x approaches negative 1? And I can see when I substitute a negative 1 in for x, this is going to turn into something over 0, and I can't deal with that. But if I look at the function here on Geometer Sketchpad, I can see that as the points get closer and closer together, I can get a pretty good idea what that slope is. And now notice when the points get exactly one on top of the other, there is no slope. So that function does disappear, but I can definitely get really close. Now there are ways of dealing with this kind of thing algebraically, like I could factor the top, and if I did that, you'd find out that it could cancel. Anyways, this is the concept of a limit, and we're just going to experiment with limits in general rather than looking at them for our slope function.